A warm welcome to everyone. In today's video lecture series, I am here to discuss on the topic solved problems in leveling. I am here to explain with the help of an example problem using a height of collimation method as well as rise and fall method. Before going to the problem, let me explain the two methods. One of the method is height of instrument method. This is a method in which the reduced level of points are measured with respect to height of the instrument. The height of instrument is found for every point where the instrument is kept, and with reference to the height of instrument, the reduced level of points are noted. This is one kind of method. So this is the tabulation to determine the reduced level of points using height of instrument method. The instrument station is marked as A, B, C and D. The first and foremost reading is marked on the back side, that is 0.9 meter, that is the benchmark reading. So the reduced level of benchmark is marked in backside reading. As I already told you, the first and foremost reading is marked as backside and the last reading is marked in foresight, and the in-between readings are marked in interside. So here the instrument is shifted to another point, so the change point is also marked here. So the second reading is 1.11 meters is marked in interside reading, and the instrument is to be shifted after the third reading. So the third reading is marked in foresight, that is the last reading before shifting the position of the instrument. So 1.05 is marked in foresight. After shifting the position of instrument, the same point, that is the change point, is viewed again and marked in backside reading. So after changing the position of instrument, the same point is viewed again and the backside reading 1.45 is marked. So how to calculate the height of instrument? We already know the reduced level of benchmark is 100 meters. If you add the backside reading with the reduced level of benchmark, you will be obtaining the height of instrument. So HI, that is height of instrument, will be equal to RL of benchmark plus backside, that is 100 plus 0.9 meters, that is 100.9 as height of instrument. So with reference to height of instrument, the reduced level of all other points can be determined using the relation reduced level of other points equal to height of instrument minus intersite or foresight readings. So here the height of instrument for first position is 100.9 meters and the intersite reading is 1.1 meters. So in order to obtain the reduced level of benchmark for point B, you have to subtract height of instrument from the intersite reading. That is 100.9 minus 1.1, that is 99.800 will be the new reduced level of the station B. Consider second reading, the point C. So the reduced level of point C can be determining by subtracting the height of instrument from the foresight reading. Since we have changed the position of instrument, The new height of instrument can be found by adding reduced level of benchmark and the backside reading. So the new height of instrument can be measured by adding the reduced level of point C and the backside reading. 99.850 plus 1.450 will be giving you the new height of instrument. Since we have changed the position of instrument, that is 101.3. From the new height of instrument, we can measure the reduced level of all other points taken from that position. That is 101.3 minus 1.550 will be giving you the reduced level of point D. This is how readings are noted using height of instrument method. Next is rise and fall method. In this method, the difference of level between the consecutive points are noted. The same problem can be calculated with the help of rise and fall method also. I will be discussing in the next video. Thank you for listening to the video. Have a good day.